In this video, we will be discussing molecular compounds, including their properties and nomenclature. Covalent bonds occur between nonmetal elements. Covalent bonds involve the sharing of electrons between two atoms. Atoms may share pairs of electrons, meaning they can share 2, 4, or 6 electrons overall. Molecular compounds are neutral, meaning there is no overall charge on the atoms or the molecule. These diagrams show the molecules methane, ammonia, and water. The electrons from the hydrogen atoms are shown in red, and the electrons from the carbon, nitrogen, and oxygen atoms are shown in blue. The shared pairs of electrons, consisting of one electron from each atom, make up the covalent bonds that hold the molecule together. The smallest piece of a molecular compound is called a molecule. A molecule is a cluster of nonmetal atoms bonded together. Molecular compounds typically have low melting points. Some are solids at room temperature, while others are liquids or gases. Remember that if a substance is a liquid at room temperature, it means that room temperature is warm enough that that substance has already melted. If a substance is a gas at room temperature is hot enough that that substance has already boiled. Since molecular compounds are not made out of charged ions, they cannot conduct electricity. The same nonmetal elements can combine in many different ways to create many different compounds, and each compound has unique properties. For example, nitrogen and oxygen can combine to form NO molecules, NO2 molecules, N2O molecules, N2O3 molecules, N2O4 molecules, and N2O5 molecules. Although molecular compounds can contain more than two nonmetal elements, we will only be naming molecular compounds made out of two nonmetal elements. Because nonmetals can combine in many different ways, the name of a molecular compound must specify how many of each element is present within the molecule. Prefixes are used to indicate the number of atoms of each element. The suffix of the second element changes to IDE, just like it does in an ionic compound. The name of the first element remains unchanged. The prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. The prefix mono is not used for the first element. All other prefixes are used for both elements. For example, the name nitrogen monoxide indicates that one nitrogen atom and one oxygen atom is present. The name dinitrogen monoxide indicates that two nitrogen atoms and one oxygen atom is present. A compound made out of one nitrogen atom and two oxygen atoms is named nitrogen dioxide. Here's a practice problem where we will fill in this table with the chemical formula and the name of each molecular compound. For the first row, we are given the formula N2O5. The prefix di will be used to indicate that there are two nitrogen atoms, and the prefix penta will indicate that there are 5 oxygen atoms. The name of this compound is dinitrogen pentaoxide. Next, we will have the name carbon dioxide. This compound contains one carbon atom. Remember that the prefix mono is not used for the first element. The prefix di indicates that there are 2 oxygen atoms, giving us the chemical formula CO2. Next, we will name the compound SF6. This compound contains 1 sulfur atom and 6 fluorine atoms. The prefix hexa indicates 6, similar to the word hexagon. The name of this compound is sulfur hexafluoride. Remember that the suffix of the first element does not change, while the suffix of the second element changes to IDE. Next, we have the compound As2Se3. This compound contains 2 arsenic atoms and 3 selenium atoms. The name of this compound is diarsenic triselenide. Lastly, we are given the name trisilicon tetranitride. This name indicates that there are 3 silicon atoms and 4 nitrogen atoms. The chemical formula is Si3N4.